Welcome back, everyone. We are now going to do a short Q&A segment on pointers. This is the most challenging topic in our class, conceptually, I think at least. And so we're going to take a little moment here to hear from some members of our class and find out where we can all improve our understanding. So with that, put your hands up if you have some questions, and we'll go through this material a little bit slowly, starting with Rebecca.
If you're keeping track of your variables with 2 new variables, how are you keeping track of those variables? Like, does it just go forever?
It could go forever, because our pointers, like pointer to x and pointer to y, have their own addresses as well. But the question is, why are you keeping track of x and y in the first place? Well, if x and y are 2 things that we want to swap, then it makes sense to keep track of their addresses separately and not just their values, because in order to swap things, it's important to use the addresses. However, you don't want to swap the pointers. There's no reason, we don't have a reason for doing that, and so we don't need to create new variables to keep track of their specific locations. So it's about what is your actual use case for it. And we're going to get to more of the use cases beyond swapping in the next hour and then more tomorrow.
And how do you choose the address?
You don't choose the address, the computer picks it for you. So if the variable is stored as a stack variable, which means it's specific just to that function, like most variables are, then when you create that function, the computer will create a whole set of spaces for each of those variables. If your variable is one of these static variables, one of the global variables we talked about, they're stored in a separate location, and the computer picks them. So that's the reason why we use the address of operator, that ampersand, is because we want to know what locations has the computer actually picked. We don't pick them, we don't want to pick them, we don't want to have to think about all the different spaces inside the computer, where to put things to arrange it ourselves. When computers were first created, you had to do that, but now it's all automated. So instead, we let the computer pick where the variables will be, and then we just have a command that we can use to figure out those locations after the fact.
Okay, great. Can I ask one last
Yeah,
question?
go for it.
Is the computer storing the value of the, like if you define x to be 9, is it keeping track of the 9 or the x? It's
keeping track of both of them. So somewhere deep in the computer, there's a list of all the memory segments, and it says, these segments are currently in use. The size of the stack is this big. But it doesn't actually keep permanently the name of each of those locations. When the compiler compiles your program, it figures out how to make those connections. So if you were to look inside the computer's memory, again, we know there are just a bunch of different locations. The 9 is actually stored somewhere. The location of where the 9 is, well, the computer can calculate that. And so it doesn't actually need to have a formal table. Instead, the formal table that it has is like, this set is reserved for all the variables. This area is reserved for all the variables.
Okay.
Getting there?
I think so.
Okay, more questions. Finn has got, okay, let's start with Adam just because he's right here, and then we'll run it over to Finn.
Okay, so is there a reason that it makes sense for the star to prepend the variable name rather than appending to the type? Because if you've got int space star x, it seems almost like it's saying...
Hold it a little further down. A little further down.
Oh, yeah, further down. Yeah,
You've got a loud voice.
It seems like it's saying that, okay, so the star is indicating that it's a pointer, but because the star is not attached to the data type int, it's almost like it's saying that the address stored at this pointer is an integer. Whereas it seems like it would make more sense, int star, this is a pointer to an integer, space x, called x.
So Adam's question is a really good one, which is essentially, why is the C syntax confusing like this? Why are we putting the star right next to the name of the variable? You don't have to. In C, you can actually add an additional space. It's just kind of conventional not to have the space. I think it's personally very confusing. It would be clearer if we used a different symbol or phrased it in a different way, but that's just kind of how it played out.
Yeah.
And you can write the star next to the type name. You can have it with a space, or you can have it like with 2 spaces, both after the type and before the variable name, or you can put it just next to the variable name.
Yeah.
And different organizations that use C will choose a different one of these styles.
Yeah, that's what I was going to ask, because if conceptually it sort of makes more sense to put the star with the
With the type.
type name because it's saying this is a pointer to something of this type, then I was going to ask, like, is it bad practice to do?
It's not bad practice,
Yeah.
but I think
just-
the style that we're likely going to use in this class
Yeah,
is to keep it next to the variable name.
Yeah, got it. Thank you.
Okay. Okay? No. What, Blake? No. Yes, great. Ah, I'm so pleased with myself with that one. Okay.
So with the swap function you created
Little further
before-
down.
Further down. With the swap function, the parameters you defined were star x and star y. Is that any different to just having x and y and then having the stars in the function?
Yes, so this is actually a crucial point, so I'm very glad you brought it up. Remember that C is what we call pass by value, which means this photocopying process is the thing that happens when we give it a variable. So if we have just x and y, I think I'm getting feedback, so I have to step a little further back. Let me do that again. It's because there are speakers over there, and so I'm picking up my own sound. Yeah, so that's actually a really crucial point. The reason why we pass in the pointers directly, rather than passing in the variables and then getting their addresses, is let's imagine we passed in x and y. The first thing the computer does when you pass them in is it makes copies of them. And those copies are at new addresses. They're not at the address of the original ones. So unless we pass the pointers in, even if we get the address later, we're going to have the addresses of the copies, not the addresses of the originals.
Okay, so when you're defining a function, defining it as in star x would be saying, okay, we're taking a pointer in.
Yeah,
Okay.
that's correct. More questions? Forgotten your name. Rex. Okay. Rex, I really should remember at this point. This is your third time, I think.
So would it be possible to store the address as an integer data type and then pass it into the function, and then instead of creating, well, you are creating a clone, but you're still
Yes.
passing in the address and then treat it as a pointer later?
Yes, but everyone will hate you for doing that. You should label
Okay.
your pointers as pointers
Okay.
so you don't mess up.
Yep.
It's just like if you want to pass the letter A around, you could write the number 65 inside an integer and make it an integer type and then cast it later. But again, everyone's going to hate you. Yeah. Pass it on.
What is the difference between a pointer and an address?
A pointer stores an address. So an address is like a number, but it's not a C data type. It's just a colloquial word that we can use to refer to a location. So
Okay, so
it's just a matter of terminology. There's no actual difference. Pointer, it's like a char stores letters and characters. So pointers store addresses.
So it's the variable would store an address to
Yeah.
something. Yeah. Okay.
Like the address is the thing that it stores. The pointer is what we call the data type.
Okay, thank you.
More questions on pointers? Hania, can you run it down?
Where?
Over there.
Thank you. Okay, so I have two, but they're small. First question is, what was the point of the dance? Like, how does that translate into the code?
What is the point of the dereferencing
Like-
dance?
But, like, what was it in the code? Like,
So this was just when you actually want to do that whole two-step thing of figuring out what address is contained inside this pointer, and then go to that address and then look at the variable contained at that address.
okay,
So it's just to say, this thing is a little complicated, it involves multiple steps.
okay. And this is a little silly, but why can't you just do the way we do it in Python, like x is equal to y, z is equal to blah, blah, blah?
So how do you think Python does it?
I don't know.
Exactly. Well, Python has to do this process that we just did using pointers. Python, you'll still have a similar kind of issue where you can have variables where if you swap them inside a subroutine, they won't be swapped in the main one. But essentially, if you do want to actually do this swapping thing in Python and actually impact what the computer is doing, someone has to have written this swapping code that uses addresses.
Right.
And so
they just
Python
have-
hides a lot of things from you. But if you want to make Python, then you have to know how to do this.
Okay, cool.
Okay, we've got time for another couple more if we have. Yeah. And I've forgotten your name.
I'm Angela.
Angela.
Yeah.
So that's a new one, I think.
Yeah. Just a question, like the difference between int star pointer and then you call star pointer again into
Yeah.
like printf. So it's the same operator, but it means different things.
Exactly.
And is that like the star pointer? Is that like going to retrieve it and then?
Yeah, so I do have a slide on that we're going to see in the next couple minutes.
Okay.
But essentially, that is the confusing thing, is the star gets used 3 ways. It gets used just to do multiplication. It gets used as the type specifier. And then it also gets used to actually instruct the computer to do this multi-step process.
Okay, and so if I pass in star pointer to like printf, that's like the dereferencing.
That's actually telling it to do the command, do the multiple step thing.
Okay.
It is really confusing, though, and that's one thing that Adam was complaining about.
Yeah.
Almost.
Thank you.
Okay, any more? Yes, Asan, and then we'll go back.
Sure. What if you want to point to a pointer? Do you have to do?
2 stars.
There isn't like a better way
No.
or a less confusing way
No,
to do it?
it's just
Okay.
confusing. And Adam, do you need this one? Any more questions of like, yeah? Yeah. So let's imagine that the question was, does it matter if I write int star or char star or, does it matter if I do int star or char star? Well, imagine that you do char star and you're trying to fetch an integer larger than 255. So you dereference and you go to that location, but when you go to that location, you're only looking at 1 byte. You're looking at a character which can only range from 0 to 255. And so now the problem is you've instructed the compiler to only fetch 1 box's worth when you're actually trying to access something that's 4 boxes worth. And that's where it becomes important. Yeah, and I don't know your name either. We've got a couple more. And then it was behind you, and then your name was Angela. Name first.
Yeah, my name's Sebastian.
Sebastian.
Now that you mentioned Python, I had a question. I remember in Python that if you set a variable like x to 5, it would point, the object would point to that. But then if I said a equals 300, then the memory address that had 5 would get automatically deleted. It would get collected.
Yeah.
What happens in C, I was wondering.
In C, variables are only created and destroyed for the most part, except with some exceptions that we get to later. There are always exceptions in C. But variables get created when the function gets created, and then they get destroyed when the function is over.
Okay.
Those memory addresses still exist,
Yeah.
but you won't have access to them anymore. But that's probably a more advanced question. Angela, let's pass it forward again, and then I think we'll move on.
I don't know if you kind of just answered it, but what's the point of passing in pointers rather than just the values itself? Is it because that values do get destroyed, but then pointers also get destroyed? So then
Yeah, the pointers themselves will get destroyed, but let's imagine I have my main function, and what I'm trying to do in my main function is, this is previewing what we're going to do a little later, but let's imagine that I have a list of student ID numbers, and I want to have all the student ID numbers in order. And I have them all stored in memory in a row. Now, we're about to talk about this, but in order to get them into the right order, I'm going to need to swap a bunch of them around. And let's say all I care about is using them in the main function, and then when the main function is over, it doesn't matter if those pointers, if the variables get destroyed. So that's why I will pass pointers to those student ID numbers to a sub-function, so that in the main function where I actually care about the order, I can have them swapped around. So even though they get destroyed later, the point is I needed to swap them for this particular part of my program. And so in that part of the program, the variables exist, and once they're done there, I just don't care about them at all.
So swapping the pointers around is not the same as swapping the values?
Yeah, but we use pointers to allow us to swap the values.
Okay.
Right? Pointers tell us where the things are,
Yeah.
and then we can just swap their locations. This is all going to make a lot more sense, hopefully soon, with regards to that specific question.
Thank you.
Okay, we've got time for a couple more, I guess. We can, yeah, we're ahead of the content anyway. So Hassan, you had a question?
Just to sort of follow up with that, is it the reason why we use pointers instead of doing it sort of without pointers is so that whatever changes we make within like the function are actually preserved
Outside
in, like,
the function.
Yeah, outside of the function.
Yeah. There are other reasons to use pointers as well, but that's one of the big ones.
Okay, that makes sense.
Behind you. And your name?
Hi. My name is Ziyan.
Ziyan?
Yeah. Like my question is like what's the difference between the static variable and the global variable? Why don't we just use a global variable for?
So imagine you have 3 functions, all of which are using static variables, and you say, okay, no more static variables, let's make them all global. And now you're writing more of your program, and you're like, oh, I need another 10 functions that are going to also need static variables. So you make another 10 global variables. And at the end of the day, you're left with like 30, 40 global variables. That's not very good because now all the different functions in your program have access to the global variables, and so you might start to mess with them. Like function B might mess with the global variables from function A. They're hard to keep track of. You don't remember their names. You might accidentally use the same name twice. It's just really bad coding practice. Ultimately, at the end of the day, inside the computer, all the variables are really global because they're stored they're stored in memory. The reason we have things like scope and global variables and static variables is to make our lives as programmers easier, so we don't start messing up variables that we shouldn't be.
All right, thanks.
And back to Finn. There is double star. Double star is pointer to a pointer. Oh, double star, yes. So you can have, for any type in C, you can have a pointer to it. That was just an example. Okay, I think we're just about ready. And with that, we'll do one last dereferencing dance to celebrate the end of our little segment on pointers. And now we're ready to go back to our regularly scheduled programming.